Today we're focusing on Cambridge IGCSE Mathematics, the topic of algebra and subtopic of linear equations and inequalities. So to begin with, we have to understand what is an inequality. And basically an inequality is any expression in mathematics that we can use symbols such as more than, less than, more than or equal to, which is basically the more than symbol but with a slight underline under that, and also the less than, which is basically the same thing but with the less than symbol with a line under that. Right, and those are all basically called inequalities. So we're going to look at how we work with them. So if you write, for example, x with this symbol and 5, that's basically like saying all the numbers of x will be more than 5, right? And similarly, if you do the next particular one, that tells me that all the values for y will be smaller than 3. Or if you go for anything with the inclusive sign, so that is when it is including the equal sign under, then this means that x will be more than or equal to 8. So it can be 8, but it can be any values that will be more than 8 as well. At the same time, the other one is any values that is equal to 10 or less than 10 also it can be, right? So moving on, if you look at how do we solve inequalities, inequalities and linear equations are very much the same. So you have to start off by trying to bring your x values to one side and the numerical terms to the other side, right? So I'm going to move this 2x first to the right hand side, so I can make it a positive 2x, and then I will move the 2 to the left hand side to make it a negative 2. So that finally I have 2 is less than 2x, which means 1 is less than x, right? Then going from there, the next thing is basically 2 into x plus 1 is greater than x minus 7. So what do I do for this? I first expand the expression on the left hand side. So I expand it out as 2x plus 2, and then I then try and move so that the x terms are on the left side, which is 2x minus x, and then negative 2, negative 7 come to the right hand side. So therefore the solution is x is greater than negative 9. Now coming to number lines, you can always denote basically inequality expressions on a number line. And how do you do that? Well, if you look at the first one, x is less than 4. So you have a number line which is basically all the numbers equally spaced written on a number, and you mark the circle there. So at that point we are saying at 4, but there are two types of circles you can use. One is shaded and one is not shaded. So in this case, because it is not including the number 4, I will use the normal circle, and from that any number below that is what is applicable in x is less than 4. So therefore you will draw a circle, and then you have an arrow pointing towards the direction of all the numbers that x can take. If you look at the next one, x is more than or equal to negative 2. So you start at negative 2, and this time I have shaded it in because I am including the negative 2, and it is all the values above that are included in the number line, right? So I am going to the right hand side. And then there are cases where x can take values between a certain range. So that is, it has to be between negative 1 and 3. So the x value is only between these two places. At the same time, because negative 1 is included, it is a black circle at negative 1, but negative 3 is not included, so it's a white circle for the other one. Moving on, inequalities can be represented even in a graph. So what you have to look at is basically the same thing as y equals mx plus c. So in this case, if you take the y equals x plus 5 equation, you know that this is basically a line going through at 5 on the y axis at the y-intercept, right? And it's a positively sloping line with a gradient of 1. That is the basic understanding that we have here. But what actually you need to know is how do you shade an expression with an inequality, right? So once you have the line in mind, the next thing you have to look at is the symbol. Is it including, not including? If it is including, then you have to use a solid line when you are trying to shade in regions, right? If it is not including, you have to use dotted lines, as you can see here. And the next thing is, if it is more than, then you have to shade above. If it is less than, then you have to shade below. So these are the things that you have to take into mind when you are shading. Moving on, solving linear equations. So equation with the highest degree of 1 is known as a linear equation. That means the exponent has to be basically equal to 1, right? So if you have x to the power of 2 or y to the power of 2 or whatever, then it is not a linear equation. Linear equation, x to the power of 1 only is the highest power that should be there in the equation. So always what you will see is that the graph of a linear equation is most likely to be in a form of a straight line. Okay. So moving on, now if I was to solve a linear equation, this is just like how you solved the inequalities earlier. So you move any negative x terms to the right side, then move all the numerical terms to the other side, simplify, and usually if there's a fraction that you can write it in a fraction. It's nice and neat rather than writing it into decimal form. And yes, you may have expressions like this. Again, the whole point is to make x the subject, right? So you have to move around and take the 4 over x to the right side, move the 10 to the left side, and then simplify that, and you have to cross multiply, and then you have to divide to simplify and get your x on its own to get you x is equal to -2. So another thing that you may need to be aware of is the fact that you should be able to come up with simple linear equations to solve your word problems, right? So for example, if the word problem says the sum of 3 consecutive odd numbers is 105, then we can try and come up with a particular expression to represent the odd numbers. Now, if you think about odd numbers, the simplest ones that will come into your mind is 1, 3, and 5, right? So if I take x as the first odd number, you can see that the second odd number is x plus 2. The third odd number is x plus 4. And that will be the general case if I take, for example, 5, 7 and 9 as my odd numbers. For that also this particular formula works. So, and rather than using specific numbers, you can use these variables to figure out the expression. So x plus x plus 2 plus x plus 4, since we are talking about the sum, should be equal to 105. This allows me to form this expression that you see here, and from there I can simplify the 3x's as 3x, and the 2 and the 4 becomes a 6, finally giving me 105. You then can remove the 6 to the right hand side to give 99, and divide by 3 to give x is 33. So that means the first odd number we consider is 33, and we want to write down the other two odd numbers, which is going to be x plus 2 and x plus 4. So that is 35 and 37 respectively. So that brings us to the end of the lesson. Let's do some questions now. Alright, so we're going to focus on doing some questions now. So how these questions work is basically you are going to solve this particular expression here. So we're going to try and move it around to simplify it to the best possible way. So what I would usually advise is if you can make it into a common denominator, then that should be the starting point. So in this case, I'm going to multiply 5 by 2x plus 3 and multiply 2 to x and make this over 10. This should be less than 17.5. So this then becomes 10x plus 15, take away 2x, and I'm also going to multiply the 10 to the other side, so this becomes 175. This then becomes 8x plus 15 is less than 175. So 8x is less than 160 and x is less than or equal to 20. So therefore, the final answer is the first option here, 20. Moving on to the next question. 9 minus 4y is greater than 5y plus 6. So again, this should be a simple case of trying to move all the y terms to one side and the x terms to the other side like this. So this is going to be 3 greater than 9y. And if I simplify this, this is 3 over 9 is greater than y, or 1 over 3 is greater than y. So basically all the values of y have to be smaller than that. And that is option number 2. And let's try and do this one. So $100 is sufficient to buy 3 shirts and 2 jeans. Okay, so let's see. If the price of a shirt is $18 and the price of a jean is taken to be y, then an inequality can be written like this. Okay, so let's understand this. They wanted the price of a jean to be y, right? So that's the first point you have to note here. So if the price of the jean is y, then 3 into x plus 2 into y, right? X I'm taking as the price of a shirt, should be less than or equal to 100. Right? And that is why they are getting this expression here. So what they have done in the next line is they are taking this 18, substituting that 18 plus the 2y, and then they are letting that to be less than 100. And this is going to be 54 plus 2y less than or equal to 100. So what I've done here is to explain to you how they have got that expression. But we are just going to solve the inequality. So in the next part, I'm just moving this to the other side. So therefore, it will be 46. And then if I divide 46, it's going to be y is smaller than equal to 23. So therefore, that will be option number 1. All right, that brings us to the end of this lesson. Tune in for the next one.
Subscribe us now for more videos and content.